So the first question is, organosine is a newly discovered element with a predicted electron arrangement of 2, 8, and so on. Okay, so in which group of the periodic table should organosine be placed? So what we are looking for in essence is the group. Okay, so we don't need all the details of the numbers. Okay, we only need the last number, which tells us the valency. And we know that elements in the periodic table that has 8, that are in group 8, which means 8 number of electrons in the outermost shell, are the group 0 elements, or sometimes called group 18 elements, or sometimes called group 8 elements for representative elements alone. So we only have the option of group 0, so this is our answer. And the next one says, which line in the table shows the correct number of protons and electrons for the atom this? So in this atom, the number at the bottom is always the atomic number, and the number at the top is always the mass number. And we know that atomic number is the same as proton number for a neutral atom, always, even if the atom is not neutral. Okay, and then for a neutral atom, atomic number is always the same as the proton number, which is always the same as the electron number. So it is when the element is charged, that is when the electron number changes. But in this case, we have neutral ion. So whatever the proton number is what the electron number is going to be. So our option is C, and we don't get to use the mass number to do anything in this question. And the third one is, which of the following molecules contains 3 atoms? The following molecules. Okay, so this tells us molecules are formed by covalent bonding, not by ionic bonding. So this tells us that our option or our answer should be covalent compounds. Okay, so any compound that is not covalent is not going to give us our answer. Now the first is phosphorus trichloride. Okay, trichloride is already telling us the chlorine is 3 and plus the phosphorus, so we are having more than 3 atoms here. Now the second one is magnesium chloride. These are 3 atoms. We have magnesium and 2 chlorine, which is 3 altogether, but it's ionic. It's formed by ionic, a positive and a negative hand. Okay, so ionic compounds form formula units and not molecules. So that is why we don't get to have this one as the correct answer. Now the next one is sodium fluoride. This is 2, just 2, made of 2 atoms, and the last is carbon dioxide. Okay, this is formed by covalent bonding. That is why it's going to be the correct answer for us. This first one is phosphorus trichloride. And the fourth question is, which bonding and structure is never found in elements? So this is where also again your knowledge of what ionic compounds and covalent compound, ionic and covalent, your knowledge of what ionic and covalent is. This is also another point where it will be tested. Okay, because covalent molecular, which is the first option, okay, has to do with molecules. So we have examples like this, like this. Okay, so molecules are bonded by that. Okay, now ionic lattice, it doesn't deal with specific elements, but one atom could be bonded to another atom. Okay, so it can deal with, let's say, sodium and then chlorine. Okay, and it's more like large lattice. But in metallic lattice, we can deal with 2 metals. Okay, so at the end, we also have covalent network. We can deal with specific elements like the graphite, carbon, and then silicon, and so on. But for ionic lattice, it deals with one ion and another ion being bonded together in that manner. And then the answer to this is ionic lattice. And then the fifth question says, which of the following compounds will conduct electricity at 600 degrees Celsius? Again, ionic and covalent. Now, your data booklet will be of help. So the first thing is, one of the properties of ionic compounds is that they have high melting and boiling point and they conduct electricity in the molten state. But covalent network and covalent compounds don't conduct electricity. Okay, so the first thing to do is to eliminate options that are giving covalent. So silicon dioxide, covalent network, which is not going to conduct electricity with this high level. Okay, and even ammonia is also covalent, so these two are not the option. But lithium bromide, a positive and a negative end, and also barium chloride, positive and negative end. These two are ionic compounds, but we only have to have one option. Okay, so in the data booklet, barium chloride in the page 9, barium chloride has a much higher melting point than lithium bromide. So the melting point of barium chloride is about 1,000, and that of lithium bromide is about 550. Okay, so it like what it takes for barium chloride to melt, it has to get to 1000 degrees Celsius, but for lithium bromide it's just 550. Okay, so when barium chloride is at 600 degrees Celsius, which is what is given us in the question, it is still not in the molten state, because ionic compounds um, conduct electricity only in the molten or aqueous state. Okay, so at that point it is still solid, so it's not yet able to conduct electricity. So that is why barium chloride is not an option for us, but lithium bromide, because lithium bromide, the melting point is much to 600 degrees Celsius. Okay, so that is why our option is B.